All right, so let's talk about orthographics. You're going to see sheets that look a lot like this, depending on if you're in seventh grade, ninth grade, you're doing one of the engineering classes. Okay, the paper will change just a little bit. There are different styles that we use. For instance, this one has the colors are laid out for you with the top, front, and right side, and then an image may be placed up here. Okay, so this is one of the styles that we use. Another style is the one that you see in front of you right here. Okay, this is what we're going to call our orthographic graph paper. Okay, it's just regular graph paper, but it's been laid out for you so you can do your top, front, and your side. Okay, so I'm just starting off with what the paper looks like as opposed to the isometrics if you've done that yet, which is just usually a blank sheet of paper or it has the 30, 60, 90 lines on it. So what is an orthographic? Well, let's take a look right here. So when we start off doing isometrics and orthographics, we can see that this is a 3D representation of what also could be seen as a 2D image. Okay, what does that mean? That means we have a top, a front, and a right side. Okay, so my top sections, this right here, and then this section right here, can be seen here. Okay, so it makes kind of like an N shape here. You see like this N that's there, and then a rectangle here, a rectangle there. All right, so think about if you're in a helicopter floating over top of this, what would you see? All right, so top is this right here. You'd see a giant, huge rectangle, right? Little rectangle right there, and then an N. The front, if I was standing directly in front of it and looking, I would see kind of like an L shape here, right? That's this right here. I would see a square in there, which is this square in there, and then I would see a square here, which is a square here. All right, and then the right side, if you look at it, I would see a rectangle at the bottom and a rectangle at the top, right? If I was standing here looking this way. Okay, rectangle at the bottom, rectangle at the top. Now, this dotted line here, this dash, represents a hidden line. Since there's like a little cove in here that we can't see from the right side, we can see it from the top, but we can't see it from the right side, we represent it with a dotted line. All right, that's what those dashes mean. Now, are there certain rules that apply to orthographics and isometrics? Yes, there are. Depending on the class that you're in, I may or may not give you these. And depending on what images you're doing, this might change. But for the most part, the rules don't change, but just what I give you might change based on the complexity of the class. Okay, so the way we look at this is if we were working off of the images that were in the front here, these original images that we talked about, and again, your colors might be different than this depending on the year and how I'm doing it. The split step is always one that's a little controversial because the side in one image can be considered the front in another. Okay, but just for the most part, depending on how your colors look, all right, whether you did the front, top, side, the slope, you did the dotted lines, the slashes, stuff like that. Okay, depending on what you did, it might vary, but the rules really don't change when we do this. Okay, so if you look here, I've got four images or four dots, excuse me. Right, this is the top T, this is the front F, and this is the side S. It's very similar to the paper that I just showed you before, right? Top, front, and side. Okay, so the whole of the image should be to scale with clean lines, meaning all corresponding lines and images, that's the drawing, must be the same length, scale, and proportion. So what does all those fancy words mean? Well, you notice how these lines are clean and neat. I used a straight edge. Straight edge must always be used when doing this. You cannot freehand this, number one. Okay? Always use a straight edge, whether you're using a ruler or you're using the triangle we use for isometrics. Doesn't make a difference. You must always use a straight edge. All right? Also, you may want to highlight your lines with a Sharpie when you make sure you've done them correctly so you can see them better. Sometimes this works really well to use a Sharpie. The problem with using a Sharpie is, and I even left an example in here for you guys to see, is that it actually bleeds through. Okay, this is actually a printed out, this is what it looks like. I actually printed out one side to the other, but this is what it looks like, right? If you do this, right, if you make these, okay, and you use a line excuse me, a marker to make the lines, it actually will bleed through. So just be aware of that. And this is what it'll look like on the opposite side, okay? So if you see this, that's why I left these pages in here. If you see this, this means you can no longer use this page for something else because the other ones bled through it, all right? And that's why I left those pages in there so you could see that. So just be aware of that when you use a marker. It makes really nice, clean lines, right, when using your straight edge, but it does bleed through. If you want to avoid the bleeding through, my suggestion is that you use you can use a pen, a black pen. That does work really well, or a colored pencil, a black colored pencil. That also works really well. Okay, so that's how you draw the lines nice and neat. So what I'm saying here when I say to scale and the same length is things must be equal to each other. So for instance, you notice that the line on the drafting table is here. The line on the drafting table is here. And it corresponds with where the slope starts here. Okay, this is where this line is. So these are all equal to one another. What I mean is the size, okay, is equal to what the image would be if it was sitting in front of me, if the object was sitting in front of me, okay? So they are the same length because they have to be the same length because it doesn't change based on where the view is, top, front, or side. And then to scale means that they're all the same size, right? We're all scaling them to the same size. Now you can do something to scale, but it'll still be wrong, and I'll show you that at number 2, okay? So it says no, lines are clean, even, parallel, and to scale. They're correctly lined up and easy to interpret. It's very, very easy to see this one. Also, what I want you to notice is that this is labeled drafting table. Okay, I can tell right now this is the drafting table. This is what this person was intending to do, and that's exactly what they did. Now, number 2 shows. Let's see if I can just move the camera over a little bit. The image shows that these are proportional to one another, meaning that they're the same size to one another, but the image should touch the corner dots. Okay, it should touch the corner dots. They're not touching the corner dots. Secondly, this is actually wrong this is the dice. This is the dice, by the way. This person never put dice on here. They never wrote dice, so that's wrong. They never put these to the 4 corners where it should be, where applicable. And one of these images is actually wrong. Okay, if we actually look, this image is correct, but again, it's not touching the dots where it should. This image is correct for the dice, but this image is actually incorrect for the dice. Okay, so again, there's a lot of ways that this can be done wrong. This just has a whole bunch of them. However, for this one, I just want to show you that this one is not touching the corners where it should be. Okay, notice how this one is touching the corners up here. All right, so what does this dice look like if it's done correctly? This is what it looks like. The person wrote dice. They have all the lines here. They're neat, right? They were drawn with a straight edge. See, it says this is correct. You can see it right there. Okay. Now, this gets a little controversial. Some people will argue the split step. Depending on how we did the split step, sometimes we'll call this the front of the split step when we're doing like the isometric, and then sometimes we'll call this the split step, or this the front of the split step when we're doing the orthographics. So you should be able to see the most detail. That's the point of an orthographic, is showing the front is the part that usually has the most detail. Obviously, depending on who the designer is, how they engineered it, things will change. All right, but for the most part, the most detail should always be shown as being the front. Okay, so in this case, this is the actual front of the image. All right, and since we show some images that have similar ends on both sides, we don't know which one is the front. We're going to default to the left. So both sides look the same. Pick the left as the default. Okay, this one from the right, more detail is visible. So pick the right as the front. So this is actually the front of this image here. The left, both left and right show detail. We're going to default to the left-hand side here. So this is going to be the front, this is going to be the front here, and this is going to be the front here. Okay? Notice that the arrow is pointing to the front of the image. All right, let me just go turn my lights back on. Okay, so we're going to call this the front of the image of the split step. Even if we call this the side, On the isometric, which again, depending on the level of complexity, what grade you're in, we'll change it up a little bit. It's not necessarily wrong, but it just depends on how either the architect or the person designing it called the front, the right side, so on and so forth. Okay. I also have this right here is the split step. So when we do the side of an image, we always show the right side. That's just how it works. The top, front, and right side. That doesn't change. When we look at the split step, and this one's hurting in a lot of different areas, but this is the left side of the split step. A lot of students, what they'll do is they'll show me the left side of the split step. So they'll say, "Oh, the side. You mean this is the side view now? Because you said this is the front." No, 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 no. We got to show the right side of the image. Okay. This is where this one gets a little confusing, and that's why I have a whole page dedicated to just the split step. Okay. So the top, the front, and the right side. Unfortunately, this is the left side. So it says the above image is not drawn to the lower dots. Okay, so we talked about that. So that's wrong there. Also, the side view must show the right side. This is the left side. You even see I wrote on the student's paper. Pick other side. Okay. So it says, note, this image is wrong for many reasons, but let's focus on the side view. You may not always see the right-hand side. However, you can infer what it looks like based on the side you can see. So we can see, if you look down here, we can see the left side, which is visible. Okay. This is the front, this is the top, and this is the slope, which gives us our front and top view. The right side is not visible. Now, if I know what the left side looks like, if I just turn this image to the side, I can figure out, just based on what the left side looks like, what the right side will probably look like. Okay? You can read this down here. This will help you to better understand exactly what's going on, and just when we come to turning the image, what it should look like. All right? And again, I'm going to show you some tips and tricks here. So depending on what grade you're in, what level you are, I may or may not give these to you, but let's just go over these. So again, we're talking about the original 12 images that we worked off of. And again, your colors might be a little bit different. All right. But for the most part, it all stays the same when it comes to drawing them. Okay. Again, the colors might be different than what you see here, but they should all be the same in your image. So for instance, this is the dado. So in this case, the dado was red. The top of the dado is red. In this case, it's blue, right? So the dado, if you look at it from the top, it's going to look like just a box, okay, with two rectangles on the side and a big rectangle in the middle. The front is going to look like a giant U, okay? On this paper, it's red, but look, it's like a giant U, okay? You see it here, and they made this color like a blue or purple. On the side view, it just shows like a square, right? If I was, now the side just happens to be green as well, but the side view here on this one, this happens to be green. So this one is also green, good, but it's just a box. And then you notice the dash is there because it shows the hidden line, which is this right here. Now, what I want you to notice is, do you see how this dash right here lines up, or this, the dado part of the dado right here lines up with this dash right here? That's what I mean when I say things have to be like proportional, and that it be to scale, right? They have to line up so it looks like it belongs together. Whether you do them in line like this, or you do the top, front, right side like you saw here, okay? These still all line up. If you notice, this line lines up with this line. This line lines up with this line. This line lines up with this line, right? These lines, they all line up. Lines up, okay? They all line up. It's the way it's done, okay? Very, very simple. There's actually a triangle that we normally would use for this, but we're not going to do it in this case, so let's just go to keep doing this visually. So the dice, okay? So again, the color's a little bit different, but let's just talk about it. So the top, so if this was the top view, if I was standing at the front and I was looking here, what would the top view look like? This is the top of the dice. This is the front of the dice, and this is the side of the dice, okay? Some people might come to me and say, Mr. C, my top and my front side look identical to each other. Is it wrong? No, there are some images where the top and the front side look identical. There's also some images where the sides will be exact mirrors of each other, okay? Like the side view will be a mirror of like the front view, okay? That happens. The steep slope, for instance. So if you look at the steep slope, in this case, the blue is the top on this one, but on this one, the red is the top. So if I looked over top of this, what would I see? I would see a big box, and then I would see the slope would actually look like just another box, right? The front would just look like two rectangles. Okay, if I was just standing in front of the steep slope, it would just look like a rectangle and a rectangle. Okay, and then the side, of course, I would just see the side of the image. In this case, it's also green, but then I have to put down the line that represents the slope. All right. The split step, again, this is the tricky one, but if we did it correctly, the split step, the top view of the split step. So if I looked at the split step, this is the front, remember? Front, right? Even though we changed it up here, don't worry about that. We just did that for isometrics just to make it easier on people, okay? The front view, if you look at it, what are we going to see? We're going to see just a block here. We're going to see the slope here, which is just a rectangle, okay? And then we're going to see these two boxes on the side. All right. You notice this is the right side of the image. Okay, I talked about showing the right side. We know what the left side looks like, but we have to show the right side. Okay, the top. Same thing. If I was over top of it, what would I see? I'd see a giant box. I would see a couple of squares, and I would see the slope as a rectangle. All right. Drafting table. Again, this is one of those ones where people are like, "Hey, Mr. C, it kind of looks the same. The front and the top they look the same, but obviously the colors will be a little bit different." And I'm like, yeah, that's perfectly fine, right? The drafting table is going to look like a rectangle and a rectangle from the top, and a rectangle and a rectangle from the front. So I mean, it's again, it's just how it works. Okay, that's completely fine. The castle top. The castle top is actually a real easy one to do. Just make sure that you highlight where your actual castle tops are. Okay, so the front view here and the side view are going to be identical. Okay, it's not going to change how you look at it. Please make sure that these are in line. Notice how this line is here, it's on the same plane, right? All right, I have a bunch of different ones on here. So again, this is also a dado, and it's correct. Okay, so the dado in here is correct. If you look, how deep it goes is a little bit different than the other one. Okay, this graph paper is a little bit different. This is more like the graph paper that you'll see for the test, depending on the level, of course, it might change. All right. If you look here, if we just look at some of these, you could just tell, you got your top, you got your front, you got your side. Okay, these are all filled in. These lines are all neat. They're all clean. They work really well. Depending on how you are doing your coloring, right? As long as you don't color over like your lines and I can't see them, this is perfectly fine. They don't have to be like, colored in perfectly, like like end to end. This is good enough. If you look here, the T block. Oh, my lights went out again. My T block. So top, front, side. Okay. And again, if I give you these, please flip through them, and you can see these are actually students' old work here. Okay, this is not stuff that I made up. These are actual students that did this. This varies between 7th grade and 9th grade, depending on of course, the year. But there's tons of examples in here to look at that will help you out. Okay, I gave you some non-examples. I gave you some ones that look good. I gave you some also ones that look bad. We could talk about these in class. Some of these are here as a learning resource. Some of these are here to see like what's good or what's bad, right? But please just take your time, look through this, kind of go through each one of these, see how other people did them. Also look at the mistakes that other people made, okay? And say, hey, if I did this the right way, what would it look like? Okay, so again, depending on the class, depending on the year, we will talk about these. We'll go over them, and I'll explain to you exactly what each one of these means. The rules are yours to go over, but please just take your time and go over the orthographics before you start drawing. Okay, the next video, I'm actually going to start drawing them for you.